$80-some thousand.
Like,
Oh,
like schooling stuff. And Trump signed that you could pass it down to like your spouse and kids.
I know a lot of benefits, like the USAA insurance is significant.
Oh, yes.
60% of what you would pay other places, stuff like that.
And Navy credit union and stuff.
Yeah.
That's what I got my college through now is the USAA.
Mm-hmm.
Okay, so let's go ahead and take a look here. We started last class, last Tuesday, I guess, looking at problems that were something like this.
Oh yeah, don't remember.
Take this as 80 feet across here, go 32 feet high. Then we had this here, we'll go 10 feet high here, we'll go 12 feet out here. And let's make this a, oh, what the heck, let's go 412 slope. We're going to start off just by finding the area. Unfortunately, this is not a easy problem. First thing we check is we check this width of this piece of the circle compared to this height. And what are we looking for there? What do we want those two numbers to be compared to each other? Half. If this is half of that, then we know that we're dealing with a full half circle. Unfortunately, the 32 here is less than half of 80, which means we're not dealing with a full half circle. We just have a segment of a circle, which means we need to extend this so that we do have a full half circle. That's really the only way to go about solving this. To do that, we need to figure out what the radius of our circle is. Start up here, we've got 80 feet across here. Up here, how do we go about finding the radius?
Put the 80 in half.
Oh, cut the 80 in half, so it's 40 and 40. And then we start with this. We'll label that purple length
X.
X. And then there's a formula that goes with it.
2 times 40 equals
32 times that. So it's going to be 40 times 40 divided by 32. That's 50. X equals 50. What's that tell us now about our diameter?
diameter is like 50.
We have to add that 50 to the 32 to get that distance all the way across. So our radius is 41. Okay, so now that we have that information, we come back here to our original drawing, and we're going to extend it down. How far do we have to extend this down here? Oh, you're close. 9 feet. So this is going to come down 9 feet here. That full half circle range. Part to remember is the center of this piece up here still drops straight down. So the distance from there out to here is what? Very good. It's still just half the 80 or 40 plus the 12. This distance now does change. It's now going to be the 41, so it gets a little bit longer. Connect that to there. I know that length is 41. degrees. And going over here, looking at this triangle.
Why'd you drop?
Because now this is a full half circle here. If it's not a full half circle, we don't know how to find the area with this little extra piece over here. Half circle, then we can cut it up the way we're doing it here. Find the area. Then we'll have to subtract this piece back out again later. Fun stuff, right? So let's look at that green triangle. This side over here was the 10 plus the 9. So it's going to be, down here we said it was 52 feet. How do I find this length here? Take it through. 15 squared plus 52 squared square root. Yes, 55.36. That's this distance here, 55.36 feet. We're gonna need that later. But I also want this angle here, so let's come back down here. How do I find that angle? Sine, cosine, or tangent there because we have all three sides now. So our angle, we're going to do the inverse tangent. 18 over 55. Sorry, not inverse tangent, inverse sine. Second sine, 18 divided by 20.07 degrees. This is 20.07 degrees here. Which means this angle here is 10.93. How did I find that? Add them up and subtract it from 180. This one, of course, the right angle is 90 degrees, and you can go from there. We know everything about that triangle. Let's talk about this purple triangle up here. Right now, the only thing I know about that triangle is that this is 55.36 feet. Can I possibly find out anything else about it? You know, the other side is 41, that's true. Good catch. You know that this angle here is obtuse. We don't know what it is, but we know it's obtuse. We need either the third side or one of the angles. Find this angle up here. Remember, this is a right angle if I do the horizontal. This angle is our heel angle for the 412 slope. That's just the inverse tangent, 412. First tangent of our slope gives us that heel angle. That's 14 or 18.43 degrees. Means that this whole angle is how much? Oh, 8.43 degrees. Got it. We subtract the 69.93 to get this one over here. They double check me on that subtraction. 48.50 degrees. Actually, might be 38, isn't it?
$38.5.
38.5 degrees there. Now we can find that missing angle, the obtuse angle there. By doing what? Well, do we have a right angle? No, so we can't use any right triangle train. So we go to law of sines, law of cosine. We check law of sines first. We have a side and its opposite angle. 40 and the 38.5 degrees. 41, I should say. 41 feet over sine of 38.50 degrees equals. Let's go on the other side. Over the sine, I'm just going to call that angle A for now. We can cross multiply and divide to get sine of angle A. Sine of 38.5 times 55.8405. Then the inverse sine, so second sine of that answer, 7.20 degrees. Is that our angle? No. Subtract it from 180. Exactly. It's 122.80 degrees. Which I believe makes that third angle 18.70 degrees. Now, while we're at it, just for fun, call this over here y. I'm going to have you find side y in your notes. Quick, see what you come up. What do we get? Do that one. 21.12 feet. I'm going to keep that there because it might be significant in a little bit. We're going to do some other things that might be useful. So this angle here was the 18.7. That's important because that tells us that this angle here is found by doing what? Adding those two together and subtracting from 180, which will give us 41.23 degrees.
Yes.
Now we're ready to find the area of this whole big thing. We have one piece right here that is 52 by 19. Triangle, so we're going to divide that by 2. 94 square feet. Our second piece, this one right here, is not a right triangle. How would I find its area? So we learned about a week and a half ago. Side times the sine of the angle in between them, right? 41 times, what was that, 55.36?
Yeah.
Times the sine of 18.70 degrees. Divided by 2, because it is still a triangle. $63.86 for that one. What's left for us? This piece out here. Sector of a circle. 41-foot radius. 5 times the radius squared. That's the area of a circle. What do I do to that to get the area of the sector? Central angle of 141.23 degrees over 360. 0.14. 31 squared. 31.2. 2070.72. Now I'm going to add these up right now, but it's not our answer. Comes up to 2,928.58 square feet. Remember, that's the area of that whole thing. We added a bunch of stuff onto here that now we have to get rid of. Like this rectangle here, part of what we subtract. That piece, called piece 4, rectangle is just 52 by 9. Otherwise known as 478. Over here, this piece is going to have to be cut into 2 pieces. I'm going to cut it here to make this triangle. This is 40 feet up here, half of the original 80. This is still 9 feet here. Call that piece 5, so 40 feet by 9 feet. What do I have to remember there? Divide by 2, because it is a triangle. It's 180 square feet. This last piece, this one right here, I need to know angle to do it. Find that angle. I'm going to just find this angle. I have the 9 feet over here as my opposite side, and the 40 is my adjacent side. That's the inverse tangent of 9 over 40. This also 12.68. Because those top and bottom are both horizontals, they're parallel lines. So those angles have to be the same. That area, 41 squared times 12.68 over 0.14 times 41 squared, 12.68. How about 360? 85.91. If I add those all up, $833.91. That is the area that has to be subtracted for that bottom piece that we added on. We end up area of 2,094.67 square feet. Grateful with that answer?
I was thinking about how that was.
We're not done yet. That's our area, but I'm gonna make it worse now.
Perfect.
So,
Well, that isn't hard if you just find the volume, there's no.
well, that's the next step, yeah. So that, let's say that this is 120 feet deep. How am I gonna find the volume of that? There you go. Take the area of that end, the 2,094.67 square feet. I multiply that 120 feet of length, or depth, or however you want to look at it. 51,360. There's our volume. The next piece, let's find the roof area. Roof area is not as bad as you might think. That's the reason I found this piece here, the 21.12. That's that piece of the roof. If I can find the length of this arc here as well, I pretty much got it down. I'm going to redraw a little bit of this so it's not quite so clustered. So I had that angle there given as 141.23. But I'm not going to use that angle. I'm actually going to take away from that 12.68 degrees. Because this part isn't really part of that arc, is it? So if I subtract 12.68 degrees, it gives me this angle. And up here, that would be just the angle from here to here, subtracting this part off. What's that give me for an angle there? $29.55. Find that, like, what's that?
It comes in.
Yep.
When you have to move.
No, because that's still the center of the circle that that arc is on. So I have to get the angle down to the center. So that arc length is found by finding the circumference of the circle. How would I find the circumference of the whole circle? That's area, pi to radius squared. Circumference is pi times diameter. Diameter here would be 82 feet. A lot of formulas to remember. Times what? Now to get the arc length. I times 82 is the whole circumference. Now if we just want this piece, what do? There you go, 129.55 degrees over 360. Giving us, that's definitely not it. Oh, I'm getting add 20 in there. 92.66, that looks better. So 92.66 feet for that portion. And the 21.12 feet for that portion. If I add those two together, 113.78. So that arc plus that flat part, that whole length is the roof. That's 113.78. Multiply that by 20 feet, get an area. We're at 13,653.6. Square feet of roof area. Well, since we're having so much fun, the wall area.
Stop it.
You ever think I missed my calling as a sadist? At every math teacher, there's a little person who's little buddies. So we already have the area of the end wall is 22,094.67. Why am I writing that down twice? Friends. Well, what is left for wall area to figure into that? Yep. Got all the roof area, so I got all this stuff up top and all the way around here. What's left? What wall? There's only one wall left. Anybody see what it is? One here. What's its dimensions?
10 by 120.
10 by 120. You got it. Of course, that makes it 1,200. Add that up. $5,389.34. Not so bad, right? Don't like finding the area of that end? Definitely is not. You know, it's not something you're gonna crank out in 5 minutes, that's for sure.
You look at time management, we figured out those last two problems in
33 minutes.
7 minutes. No, 7 minutes, and the
Oh,
other
yeah.
one was 26 minutes. And
Moral of the story is, you know, keep my phone number handy and, you know, work for consulting.
so someone comes, drives me up something like this, I might just.
You find somebody else
I build triangles and squares.
I know a great guy. His name's Todd.
for the right price.
I'll get real lucky if my triangles ain't at 45 degrees. Come on.
He and Vic and Hooch.
Looks like an army camp.
Yeah, no,
From World War.
Gomer Pyle.
These were very common in military establishments, yes.
David was born on one of those.
Oh, don't kid, David wasn't born.
That was Hatch, exactly. Get on the right side of the hill. Or was rolled down.
Such love, you can feel it flowing, can't you? We'll call this. And let's see, let me do the root kit. So, looking at something as beautiful as this, I want to find the volume of it.
Sounds like a headache.
Kind of looks like a Swiss.
Weird bump on it. That's appetizing. When I ask you to find the volume, I am really creating two different problems here. Problem number one. One like we just did. Find that volume and then add in the .12 feet of length. Where'd that 12 feet come from? Not 12 feet, sorry. That is the length of that portion with that little
Oh, so you just
lean-to on it. All I did, yeah, I just took this and I cut out this piece right here. That's all we're looking at, actually, cut that piece out, and we're just looking at that right here. So I can find this area and multiply by 18 to get the volume, just like we did in the last problem. We'll come back and look at that in a minute. Second problem, part of this problem, however you want to look at it. This. Where the 62 feet come from there?
18.
Yep, we took the 18 away from 80. That's basically taking these other two pieces, since they're identical, we just slap them together to make one big piece. We'll find the area of the end of that. Multiply by that 62. There. Oh.
There's different meanings.
Yes, I know. I'll give you that one. We'll do this. X. What do I do from there? 30 times 30 equals. Gives us what? Five equals X, isn't it?
Then we'll go with that.
Double check. diameter. Yeah, just goes to show, say something. This- How much do I need to add on to the bottom of this thing? It's 18, I need to be 34. From the center out is still how long?
Half of 60.
Half of the 60, so it's 30 feet here plus the 10. From here out to here, however, is no longer 30, it is now, had the right idea, 34. It's 30 because, yeah, this will go out, but whatever we lose here, whatever we gain here, we would have lost it over here. Down rather than going out with the curve. That's why that stays the same. Draw this triangle in here. How can I find the length of that green line?
16.
Squared plus 40 squared, the root, 43.08. You guys catching the rhythm here? How do I find that? What's that angle? Somebody tell me. Oops, that's not 43.08. What did we do wrong?
Oh, it's gotta be 24.
Good thing I caught that before we. 46.65 we get. That looks a little bit better. How do I find that angle? Somebody find the angle for me. Oh, this is 90. Yep, this is the one I'm looking for right here. Get an answer? $30.96.
Yeah,
Inverse tangent of 24 over 40.
yeah, I just didn't do.
Answer. That makes this angle up here 59.04 degrees. Yep. Find for me in your notes again what this complete angle is here. 90-degree angle, and this is the 312 heel there. Anybody?
Yeah.
What do you have?
Well, that is 14 point.
Yep, so the whole angle is
104 point.
4.04, good. So that means this angle is 104.04 minus the 59.04, 45 degrees. Could we get made that happen again? Find that angle for me. Redraw it down here for you. Careful. Where's it 104? What everybody else came up with? That's it, it's 104. Which means that this angle over here is 30. And now, since we know this is 30.98, find that angle for me. $18.06, very good. Now, one, two, three pieces. Find the area of those three pieces. one, did you get 480 square feet?
Yes.
Oh. These two, did you get 299.3? Okay, good, you got 408.21?
No,
No?
that's 420.22.
So it's the 34 times the 46.65 times the sine of the 30.98.
Yeah, that's
Yeah,
what
I
I
bet
thought
you-
I do, unless I might have typed something in wrong.
I've got mine actually typed in. Correct, so let me check yours. Yep. I won't.
Was the rate
34. $1190.39.
Yes.
$2,078.60 for that area. Okay, now, let me figure out the pieces you gotta subtract there. There are three pieces. Draw them for you. I'll call it pieces 4, 5, and 6. There you go.
Yeah, like the blue line you just drew.
I haven't calculated that yet. I'll show you though here. This angle right here comes from the fact that this side here is 16 feet. That's what we added on.
Yep.
And this here is the 34 feet. That's our radius. 254.09. $4.09. So we add up those three pieces that we have to subtract out, we get 1166.09 total. Subtract that 1166 from 1078.60 that we had before, we get a difference of only 912.51 square feet. That is the area. I think you guys have suffered enough for the day.
I gotta finish it up.
Multiply by 18 to get the volume.
That 18 by 6.
Then this one here, you can find the area, the area of that easement. This is the area of the segment. Know that you're going to extend that down, and this is going to be 34 feet, right? Find the angle here. Find that angle. I can trust you guys to handle that part on your own, right?
Google will help me.
Google will help you.
Or give me the phone.
Now, just to make you guys feel better. God, it makes me feel old to think about it, isn't it? State of Wisconsin did a mandate on the technical colleges that we had to restructure. The general classes had to be restructured. And the UW system was basically claiming the math we taught was not college level, which the first 3 weeks of last fall, I agree with it. It's not college level math. So I had 3 friends at the time that were math professors at UW Eau Claire, so I took them a problem very similar to this one. And after 2 weeks, I went back down and visited them again. One of them had a solution, is that correct? Another one asked me for a hint. And I gave them this hint of adding this piece on the bottom here like that. The third one refused to discuss it with me. I made it back down there about 3 weeks later, and the second one did have an answer that was correct, but he couldn't have got it without the hint I gave. So if you're struggling with this and you're getting frustrated, just remember only 1 out of 3 math professors at UW Eau Claire could do this wrong system. There's a reason why I let you guys do everything in groups here for the rest of the semester. There will be a quiz coming up that'll have a problem like this. For right now, I want you to keep working on that worksheet we started last Monday. There are some problems like this on there. Tomorrow we'll probably move on. I'll probably get you ready for the quiz today. After tomorrow, and then we'll move on to some new stuff. You guys have a great day. We'll see you tomorrow.
You too.